Right. Now we are moving to the next part. I told you the next three topics are related to mostly designing. Okay, designing. And little bit of modeling is there, but modeling is related to both analysis and designing, right? Right. So designing. So once you understand the requirements, right? So the next step or next task is we have to come up with a solution. Right? We have to come up with a solution. So that is what the software developer's task. That is what the software engineer's main task. Right? So come up with a solution and develop it. So if it is a simple thing, we can straight away develop the solution. But when things are complicated, complex, we always design and then develop. Right? First we design, then we develop. Okay. So why we want to design and develop? First thing is obviously developing a solution. No, identifying a solution is a challenging task. The other thing is there can be some possible options. This solution, that solution, and stuff like that. So then we want to find out the best solution and we want to develop that best solution, not a solution, the best solution. So we can evaluate these different solutions at design level rather than you develop and evaluate. So it's costly. It's costly. So, but evaluating at the early designing level is easier. Okay. Right. So now let's see what is mean by design. Okay. So designing means you first come up with a solution or set of solutions, then you model the solution. Model the solution. So this is the main part of the designing. Okay. So we have to come up with solutions. We have to model the solution or the solution sometimes. And also we have to evaluate solutions. And this is very fussy. We can't say that it is happening in 1, 2, 3 sequence. No, it can happen as a mixing things, right? So while solutions comes to our mind, we do some evaluation. So these solutions we tend to model. So therefore these three things are not sequential. These three things happens as a mixture, right? And also we do these things as a team, not just by one member. So the different senior people, they get together and come up with these solutions, evaluate those things, model those things. It's a very interactive process. Okay. Right. So the final idea objective is generate many solutions, pick the best solution and model it so that the development team can understand the solution and then they can start developing it. Okay. So therefore it's a evolutionary process. It's a refining process. You can't generate the best solution as the first thing. So you come up with a solution and you refine it. You find some issues, you find some room for improvements and you refine it. And then only you start developing. Okay. Start developing. And while developing also, we can even refine it further. Okay. So that is the idea. That is the idea of designing. So when it comes to modeling and also when it comes to the design, there are different ways or different aspects. First, we have to come up with high level design. High level design. We call it architecture. Right? The high level design is called architecture. So then once you settle to architecture, once you pick the architecture or the best architecture, then we can go into detailed design. Because detailed design heavily depends on the architecture. Okay. So that is why when you know that if you start your career as a software developer or software engineer or associate software engineer, So you can go up, senior, the software engineer, senior software engineer. So the next level is something like tech lead, solution architect. The highest level is the software architect. Okay, software architect from the technical track. Right? Of course, the project management track, we have the project manager. So you can't say that whether the software solution, the software architect or the project manager is the, of course, the project manager is the main person. But sometimes your architect get higher salary than project manager. Right? So that is widely happening. Right. So architecture. So come up with the architecture and then do the detailed design. And again, these architectures and designs will depends on the way you develop it. Remember, again, we have the structured software development, structured approach, object-oriented approach. And certain things are common, but certain things, especially detailed designs, are heavily depending on whether you go for structured or object-oriented. Okay, so the way we design systems in a structured way, we have certain concepts, and the way when we look at or when we design a solution using object-oriented, definitely we have different way of thinking, different concepts, and that means different architectures. Okay, right. So in your syllabus, it's a very strange way they have structured it. They have taken architectural design to the third level. I don't know. I don't know any reason why, because architectural design is something we do first. Okay, before even anything else. Okay, so therefore I'm going to discuss this first. Okay, so what are the possible architectures? Architectures are the high level things. Okay, and anyway, before moving to that one, we'll look at the big picture. Okay, so then when it comes to designing, we tend to design different aspects separately, because when you separate our concerns, it's easier, right? So initially it looks very complex, right? Designing software is a complex task. If you think everything together, because you know that, okay, I have to develop user interfaces, some business logic, database, we have to integrate with other systems. If you start thinking everything together, it's a headache. Right? So we use something called divide and conquer. Divide and conquer. When you break it, it's easier to defeat it. We will be more ease. So therefore, we can design different aspects separately. There are some common aspects as well, but mainly we can, okay, now forget about the architecture. Once you have the architecture, we can design the user interface separately. So that is why you have a subject called user experience design. Okay, user interface design. Okay, so then you can design the database separate, your data, which we already discussed, right? ER diagram, normalization, right? Your conceptual ER, you can convert it to design ER, then that you can further convert into physical design, right? So database design, user interface design. So then of course you can have program design. So that is your main business logic and other things, the component wise and how they interact with each other, program design. So this is one of the main tasks. So then you can have designing of the interfaces, system interfaces, just like user interfaces. You have to design how are we going to integrate with other systems. System interface design. For this, we have already covered database design. So program design is what we are going to discuss, continue with object-oriented SAD, and we did bit of those things in project programming, right? Data structures and algorithms. So this is our biggest topic, the program design. So you have semester 3, you have a subject called user interface design. So semester 4, and you have semester 4 another subject, enterprise application development. So it's all about system interface design, like enterprise Java beans, message-driven beans, entity beans, right? Remote method calls, heavily technical subject. So we are going to learn those things in different subjects. If it is a mobile application, there are some specific design concerns because mobile phone is a small device and it has some integrated with some other features. So therefore you have the mobile development as a special case of user interface and program development because it has less resources. Likewise, we can separate different aspects, design in different aspects. Okay, user interface, database, program, system interfaces, and if there are special cases like mobile. So that is one way of tackling this complexity. Okay. And we are covering those things in different subjects as well, rather than commonly. Right? And also high level and detail, architecture and detail. And another way of looking at designing is logical design and physical design. Right? Logical design and physical design. We already discussed this for databases. So logical design means technical independent. Conceptual level, we design the solution. For example, database, we can design at entity level, primary key, foreign key, etc., indexes, etc. Without referring to a technology. We are not concerned whether we are going to use Oracle or MySQL or Microsoft SQL. Once you pick the technology, we have to refine your design according to the concepts available in different technologies. Maybe one particular concept is available in Oracle, but not in MySQL. So therefore, you can refine your logical design further according to the technology. So then we call it physical design. For example, when you have your class diagram, first you do it little bit in technology independent way. But if once you decide, okay, I am going to use it Java. No, we are going to use C#. Now you have to refine it because C# has some concept which Java does not support. Java has some concepts which the C# doesn't support. And if you take something like PHP, it supports certain other concept and it doesn't support quite a bit of concept that both Java and C# doesn't support because PHP is not a very good object-oriented language. So a lot of object-oriented concepts are missing in PHP. So we have to refine it. So there is a difference between logical design and physical design. Okay. Now we can see that there's a concept called logical design and physical design. There's a concept called architecture or the high-level design and detailed design. And at the same time, we can design different aspects separately while we have the overall idea. Okay. Right. So I hope now you got the big picture. And also again, designing, we heavily try to do it in a graphical manner, pictorial manner, right? Because I keep on telling that as humans, our brain is optimized to understand pictures, not text. That is why we heavily use diagrams in designing also. In analysis, remember, use case diagrams, context diagrams, blah, 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 even ER diagrams, the analysis ER diagrams. Here also we heavily use architectural diagrams, class diagrams, sequence diagrams, design database, ER diagrams, etc. Okay. Right. So let's move on. So I'm going to start with this part, architectural design. Okay. Because for me, that is more natural to start from there because first we do the high level design and then we go to the detailed design. Okay. Right. Architectural design. So architectural design is concerned with understanding how software should be organized and designing the overall structure. So there is a big picture, right? Overall structure, how they are organized in general, how your software is organized, and what is the overall structure. Okay. So the output is architectural model, right? Remember, model is abstract representation. It describes how the system is organized as a set of communicating components. Right? So in this designing, we heavily show how they communicate. Right? This component is communicating with that one is communicating with another one. Okay. Right. So this is, they are just showing some example. Now again, we use the word abstraction. I told you the importance of abstraction. එන්සිනාටයි අපිලිම්මාමටයි නැත්තෙත් ඕකයි කියලා නේද abstraction එක නැති හන්දනේ මේ එක එක මගුල් හොය හොයන්නේ concept ගැන කතා කරන්න බැරි හන්දනේ නේද. So architectural solution is design is also abstraction of your big at high level how your system is going to be structured and how they are going to interact with each other. Okay. So it's again, whenever we say modeling, it's abstraction. Okay, whether it's requirement or solution. Right. So why we need a explicit architecture upfront? We have to agree that this is the architecture we are going to use when we are developing this system, when we are developing this solution. Because our deciding on the architecture is a major decision. It's a big decision that we have to agree early. Okay. Because depending on the architecture, there can be some limitations, there can be some opportunities which we have to agree. Otherwise, there will be some conflicts at the latter part. Okay. Right. So there are different architectures available, different architectures. Okay. And we can't say this is the architecture for that problem. Often your solution will be mixture of architectures, right? Mixture of architectures, but you will be able to identify the key architecture. The key concept is this, but we are going to use these architectures also as a supplementary for these aspects. So that is how you do it. Okay. And there is a overlapping. So that is why these architects are very experienced people, software architects are, because they must have a lot of experience, exposure. They must have see how the software is developed, how the software has failed, how the software has success. So they know that, okay, this architecture worked, this architecture failed. This architecture work better than the other architecture. So that is why software architects are some experienced people. Not only experienced, they are highly talented. Not everyone, remember, in software development, just because you work in that field for 5 years, you won't become a software architect, and sometimes you will never become a software architect unless you have that talent. Okay. Because experience is not count by number of years. It is what kind of challenges you have faced, what kind of challenges you have overcome, right? What kind of diversity you have faced. Maybe you have been doing only some same type of things, right? Say your job is doing the same thing. Say, I'm not saying that some jobs are bad and some jobs are good, but this is the reality. Okay. Say your job is just doing the same thing every day. Now, if that is the case, it doesn't mean whether you have 5 years of experience or 10 years of experience or 20 years of experience. because you can be easily replaced by a new person. He will say, okay, I will also do this. So that is why for that kind of jobs, you don't get a salary increasing in salary, because after 10 years also, your task is just like what you did in the day one. So why do they want to give you higher salary? Because you can be easily replaced by another new person. So you have to think about those things. Okay, unfortunate reality. But every time, right, every day, each experience of each day is going to count, make you a better person in that practitioner, make you a better professional. Right, your value is getting higher and higher and higher. That is where you get higher and higher salaries, because that experience is needed, right? For example, when you say you one of your relations or parents want to do a need to have a little bit risky uh, operation. So do you just go for a doctor, or you are keep looking for the best doctor in Sri Lanka? So you are looking for the best doctor, right? Maybe his fees are very high, right? But you don't want to take a risk. Of course, people always take risks, but some people, they don't want to take any risks. So they go for the best, or the person having the, when I say experience, it is not counted on years. It is what kind of challenges that person has overcome. That person has successfully countered, right? So therefore, these decisions are taken by very talented, experienced people. Okay, architectural design, and also it involves a bit of creativity as well, because there are so many solutions. So our task is identify the best combinations. Right, bit of creativity, bit of courage is needed. Okay, and it's both technical and non-technical things we have to consider, right? Business level things, technical things. It's a mixture of things. Just because you are really good in technical things, it doesn't mean that you are a good architect. So you must be as good as your technical things. You must be as well equipped with your understanding about the business processes, because ultimately your software is going to be used for business. Okay. So therefore, it's a multitude of skills are needed. You have to look at a lot of aspects when you decide on architecture. Okay. Right. So there are a few things we have to look at. We have to think when we decide on architecture. Right. So we have to think about the performance. We have to think about the security, safety, the availability, maintainability, maybe upgradability, scalability. So all those has to be looked at, and then you decide on what is the best architecture. Right? What is the best architecture? Right. So this is a big decision. Okay. Deciding on the architecture is one of the key decisions that is taken by very experienced, talented people. So I told you that when you are deciding on architecture, it's not just you can look at one aspect and decide. We have to look at a lot of things. We have to look at it as a logic. What is the best solution for this kind of a problem? Which architecture is going to give you the best solution for this kind of a problem? The technological specific things, the physical view, because you must have some idea about what technologies are you going to use. For example, if you are going to use Java, you know that Java favored certain architectures. Certain architectures can be best implemented using Java, and some other architectures maybe we can best implement it using C# or maybe Python. So that is a physical view. Right? again, that means you can take those decisions if you have experience with working on those technologies. If you know only Java, of course, or if you have only worked with MySQL, so how do you take that kind of decisions? Because you know only one thing. So then you will all අහලා නේද? ඔයා මිටියක් නම් ඔයාට හැමදේම පේන්නේ ඇණයක් වගේ කියලා නේද? So if you are a hammer, you will see everything as a nail, because that is what you know. If you know only Java, you go everywhere and say that the Java is the best. Java is the best, because you don't know anything else. If you know only about C#, you go everywhere and say C# is the best. But if you know multiple things, then you can do those judgments. Then you have to think about the process view. Are we going to develop it in which software development process, the business processes, and the development view? The limitations in the development process, the availability of the developers, right? Their knowledge on certain things. For example, say our development team is not having a lot of knowledge on MVC frameworks. So then if we come up with an architecture which is heavily MVC, so the development team will not be able to develop it. We have to think about so many factors when we are taking those decisions. Right? We have to compromise. Maybe the best architecture is something else, but that architecture is not going to work with our development team. Our development team is not capable of handling that kind of thing. So we have to, it's a compromisation. Okay, it's a compromisation. Right? The logical views, the key abstractions, the process views, how the business process is going to happen, the development views, right? How the software is decomposed for development, the physical views, system hardware and software related, technology related things, right? So likewise, we have to look at those things. Okay. And people are trying different ways to come up with the best architectures. Right? So the UML is there, Unified Modeling Language. Okay. And there are some other alternative approaches as well. Okay. Architecture description languages and some alternative ways also the software teams are trying. But these still the most popular approach is the UML diagrams, right? So that is where you have different diagrams like class diagrams, etc. But class diagram is not an architectural view. Architectural view is even higher level. Okay. And there are some architectural patterns. Okay, architectural patterns. So when you get more and more experience in your career, you will see that there are some common architectures or architectural patterns that work in different scenarios. So that knowledge is sort of formalized or documented by software development professionals as architectural patterns. Okay. So they have given some given names for those patterns, those architectures. So then we have a terminology. We can, rather than explaining that architecture, we can say, okay, let's use MVC architecture. Let's use layered architecture. Let's use repository architecture. Otherwise, we have to explain it. It's time consuming and we are wasting our time. But if we have given some names like labels, rather than explaining, we just say, let's use layered architecture. Then the other architects, other designers, they know. Then they can say, no, this layered architecture has this drawback. Otherwise, before getting that feedback, you have to explain that because you are not using a word. So that is why we have, the software developers have come up with, designers, architects have come up with some names to well-known architectures. Okay. Right. So these are some of those well-known architectures, right? Not the low-level patterns, architectural patterns. The most popular architectural pattern is model view control pattern. Okay, MVC pattern. So we will be discussing this more details when in your web development. Remember the other subject we are behind is web development. We just did HTML, I think, right? Maybe a bit of CSS. So we have to do a lot of other things, Bootstrap and so many other things, okay? XML. So especially in web development, we heavily use model view controller pattern. In semester 3, you have again web development 2. So good part of web development 2 is understanding the MVC pattern in the server side. Okay, in the server side. So they are high level. You look at your software as set of models, controllers, and views, especially in web development, like client server software development. Not only web development, we can use it for standalone applications also, like Swing, C#, C#.NET, MVC architecture. So there what happens is when a customer or client or user want some functionality, his or her request is initially sent to the controller, or user's actions are mapped to the controller. Controller is the controlling part. Okay. So then it will delegate it to the model, especially if you want to get some data, retrieve data or save data, because that action can be saving. Okay. Doing a transaction, or that action can be just looking for something, searching something. So database related things or data related things are given to the model. So that means controller calls the relevant models. And models are the one that communicate with the data or database. Okay. And it will generate the result. Maybe just a success or fail. If it is update or delete or insert, but if it is a retrieval, now your model has the required data taken from the database. Now you have to load that data or that information into a view, because ultimately it is the view that is sent back by the controller to the end user. End user get a view, right? Controller do the overall controlling, especially the data related things are delegated to models. Models interact with the database, and that result is given to the view, which is presented to the user again. Now again, user can do action like submitting a form, etc. Again, it is controller that take care of it and delegate working with database to relevant models, maybe account model, account class, or maybe invoice class, or maybe payment class. And again, the result is filled with the views, and the view is given back. So that is called model view control, MVC architecture. This is heavily used. Actually, more than 90% of the time, when a web application is developed, we use MVC architecture. Okay. Whether it is Java or PHP or ASP.NET, we more than 90% of the time, unless it's a very small application, we go for MVC architecture. Okay, so this is the MVC architecture when it comes to browser or the client server application, web application. Okay. Anyway, in the exam, they are not going to ask any of this. They will just check whether are you aware of the concept of architectural patterns, and maybe what are some popular architectural patterns. Okay, you don't have to worry about how the MVC really works, because that is covered in your semester 3 web development. Right, so that is the first architectural pattern, model view controller. Okay, so the second architectural pattern is layered architecture. So here we look at the system architecture as set of layers, something like this. And lower layers provide some facilities, services to the upper layers. ultimately the end users are really interacting with or interested in this upper layer. But upper layers cannot do their task without the help from the lower layers. So that is called layered architecture. So very good example is we understand the computer system as a layered architecture. Of course, you know that computer, we can look at it like that, but reality, we look at it as hardware, firmware, system software, application software, and if you want, you can even consider them users as liveware. Reality, we are interested in application software, maybe accounting system, order processing system, or open office. But application software need the help from the system software, especially the operating system. The operating system need the help from the firmware in order to communicate with the hardware. Ultimately, your stuff is processed by hardware, your microprocessor, saved in hard disk and temporarily in memory. They are all hardware, but it's a layered architecture. Each layer is providing service to the next layer, right? And ultimately the application software. So that is layered architecture. Another very good example of use of layered architecture is networking. Those you have done little bit of networking already know, and we did bit of networking in semester 1 under computer system. So we discussed about OSI architecture, 7-layer architecture, physical layer, logical link layer, network layer, transport layer, right? Session presentation and application. So that is clearly a layered architecture. So that is how you understand computer networking, how the internet work, how a local area network work. It's architecture and it's very useful, very, very, very useful. So you can see that layered architecture cannot be used everywhere, but there are places, and those places are extremely important, critical places like network, understanding the computer itself. Okay. So they have given some examples and other things. Okay. So this is one example, right? Your OS, your business logic, user interface, management, and user interface. Okay. It's just an example, okay? Right. Now we are moving to our next architecture, repository architecture. So repository means a place where you save things, you keep things. Okay. It's something like a safe, something like a bag. So repository is where you keep things so that later you can retrieve. And you keep or save things and later you can retrieve. So that is called repository. So this is a concept, abstract concept. Repository is an abstract concept. So that abstract concept can be used when you are designing certain applications. For example, database is a repository where you keep data. File server is a repository where you keep files. Even something like YouTube is a repository where you keep your videos. Right? So then there are repositories for your images, your documents, CMS, content management system like WordPress, Drupal. So they are also repositories. Okay. It's an architecture. You keep things in a central location and access it from there. Now remember, we are heavily talking about the cloud computing. So it's all about we keep things in a repository. Okay, so it's architecture. And people are building different applications based on repository, just like MVC. And clearly you can see that a software can be developed by mixing both repository and MVC. Of course, we are using MVC, but we are connecting to the database. Database is a repository. So we can mix those architectures. Right. Another architecture is client-server architecture. Right. Client-server, and also we have the peer-to-peer, two different architectures. So in client-server architecture, we have clients communicate with server. So this is where the service is given. Right? So that is what happens when you access your VLE. That is what happens when you access your banking system through telemachine or online banking, client server. So server is there to serve. The clients can send the request and consume the data or whatever. And of course, this can be subdivided because one of the biggest issue here is the best thing about this architecture is we have the central control, very good control, because your data is at your side. Your logic is at your side. But there are issues like scalability issues because everyone is connecting to you. Right? And net security concerns because data has to transfer through the network. Okay. Performance issues. So that is why people are now heavily using not only the client server, we can subdivide into centralized client server, distributed client server. Distributed client server, you get less hits because not one server, we have multiple servers. Okay, multiple servers. Right. So that is another architectural pattern. Okay, another architectural pattern. So you can see that when you are developing systems, actually what happens is in reality we use client server architecture, we use repository architecture, at the same time we use MVC. Most of the time we use all three together at different levels, at different phases. It's a mixture of these three architectures, okay? Right. So they have mentioned few more, actually they have not mentioned the peer-to-peer. So because they have mentioned client server, it's always good to know the peer-to-peer as well, right? So we discussed when we are doing the web development, right? Peer-to-peer, it's not client connecting to the server. We have peers. They are sort of equal level. They can both serve and consume, okay? Like cryptocurrency networks, right? Or maybe something like BitTorrents. So those are peer-to-peer architectures, okay? Right. So this is another architecture. This is not very popular one, but there are some usages of this pipe and field architecture. So when you know these, aware those architectures, when this one of these architectures are suitable, it will come to your mind. If you are not aware of that such an architecture is there, the solution may be there, but you don't know exactly what is how to represent that solution. So when you know these architectures, you know that I can use this architecture, that architecture. Okay. So in pipe and field architecture, the functional transformation process their inputs and product outputs, and then they can give it to another. So X will take input, process it, and that output it can give it to the Y for different type of processing or further processing. So that is called pipe and field architecture. Okay. And you can see that it is more biased towards batch processing, not for interactive systems. Okay. Batch sequential modeling. Okay, pipe and field. It's a little bit of outdated architecture, but still there are situations we do batch processing. Right. So let's discuss few more architectures, but this time it's not the general architecture, so the high level architectures. Okay, so how do you call these things like MVC, client server, repository, etc.? We just call it architectural views, or those are the big architectures. Now what we are going to discuss is application architectures. Okay, application architectures. So they are a little bit low level architectures. Okay, low level. So these are just examples. Okay, so you just have to know that, okay, if someone is mentioning about this, these are application architectures, not the big architectures. Okay, data processing applications, transaction processing applications, event processing applications, language processing systems. So depending on the right, so depending on the application, we can identify or we can propose a solution or an architecture as a solution, part of the solution. Okay. So there are some data processing applications, right? So they are heavily data oriented. So our main concern is processing data, processing data. Like if you take something like there are some data mining applications, right? Something like Google. So their main task is process your data and come up with some information, meaningful things. Then there are transaction oriented applications like banking systems. It's not data, it's transactions, right? Money transfers, payments. Okay. If you take supermarket billing system, so it's a transaction oriented applications. It's not just data, right? If you take something like weather forecast, it's a data processing application. Okay. Then we have event processing systems. So their main concern is responding to events and responding to events. Like some control systems, manufacturing related things, robotics, Internet of Things. So they are pretty much event processing systems. So their task is responding to events. And of course, they also have to do processing, right? Data processing, but the main concern is, main focus is quickly respond to those events. And this is another example they have given. This is just example, okay? Language processing. So that means you have to process languages like natural language processing. Like for example, if you take something like Google Transliterate, it's a language processing system. Right? So when you type, it has to guess those bad things, right? And of course, the Google Assistant, Apple Siri, they also have to do some language processing. Okay. Language processing. So they are just example of applications, right? And for different type of applications, there are different architectural patterns or architectures or mixtures we have to go for. Right? So they have given example, right? Reservation system, e-commerce system, they are transaction processing. Compilers, command interpreters. So that is not natural language. This is more into the programming language processing. So they are language processing. Okay. And you know what is transaction processing system, etc. Okay. Right. So I explain you the separation of concerns, user interface design, right? System database design, right? The application communications, right? Etc. Integrations. So I explained that earlier. So we can look at those concerns separately. We can look at those separately. User interfaces, enterprise application integrations, database, retrieval of data. So we can propose different architectures for that. Okay, sub-architectures at different levels, at different aspects. This is sort of a different levels. User interface is the highest level, then the communication, then the information retrieval and modification, and finally the database level. Right. So these are some examples they have given. Okay, web-based information systems. Right. Server implementation. So you will be learning these things when in the level 2 we have a subject called enterprise application development. It's a very technical subject. You will learn how to write servlets, JSPs, the web services, enterprise Java beans, entity beans, session beans, message driven beans. Right? It's pretty much Java again, but not learning Java language, learning how to develop enterprise applications. Okay, and there we are going to learn these architectures. Right? So language processing. And so compiler and other things are sort of a very technical things like processing, how to convert your high level programming code into the machine code. So that is also something, sometimes we have to not only develop order processing system, inventory processing system, sometimes we have to develop a new language. So there also we have to come up with some architectures. Okay. So there are software developers who come up with new languages. So there we can use these language processing systems related architectures. So they are given some examples of use of pipe and field, etc. Okay, right. So that is architecture, right? So that is architecture, right? So we covered architectural design. Okay, architectural design. So still we didn't discuss the system modeling and design and implementation. Okay, so our next topic is system modeling. System modeling. Okay, so I told you these three are highly related, very highly related. Okay, right. So now I am moving to the system modeling note. I took the architecture because architecture is something that we do upfront. Now here we are going to discuss some general concepts. Okay, general things. Right. So what is mere modeling? So I told you model is abstract representation. Right. Model is abstract representation. Just like we had use cases, right, etc. Here also we can have different abstract representation. Maybe ER diagram, the class diagram, sequence diagram, and so many, especially in UML. Again, these things are going to be covered in your object-oriented SAD, most of these. But your course coordinator wanted to have those things in this subject as well, software engineering as well. Okay, so therefore, here we are going to just give you the feeling about those models. Okay, design artifacts. Right. So when you're modeling, you can model how the existing system work. That is more analysis. And how the planned system work. That is the architecture. That is designing. Actually, this is analysis. We analyze how the things are happening. Then we model. Here also we model, analyze and model. Here we model the solution, planned system. Okay. So we can even model the planned system, how the functionalities work. Because when we are developing a software, it is not just automating. We sometimes, not sometimes, most of the time we change the business flows, business process. Because if we can find a better way of doing the business process, it's not only software is introduced, we change the business flow. It's a new way of doing things. New way of doing things in a new system with the help of a new system. It is not that old way we are automating. So that is a big mistake. Some people, when they look at software development, they think that we just want to automate it. No. We want to look at the better ways of doing things, better restructuring of the process, the business flows, and that new business flows we are going to develop with a new architecture, new design. Okay. So that is the idea. right? And again, when you are designing, when you are modeling the solution, we can look at it in different perspectives. Perspectives means different viewpoints. Okay. Remember, we explained that user interface design, application design, database design, system integration design, or the models. So this is also a little bit like that, but this is a different way. So we can look at the system external perspective, interaction perspective, structural perspective, behavioral perspective. So this is the most widely used two terms, structural and behavioral. In UML, we are going to subdivide when we are doing the UML in semester 3. We subdivide each and every UML diagram into either structural or behavioral. So structural perspective means you look at the structure. In general, how the things are structured. Okay. So the most important diagram in design is, other than the architectural diagram, the class diagram. Class diagram. So class diagram is the main structural diagram. It shows how the classes are related. This class is inherited from that class. This class is associated with this one. This class is depending on that one. This class is composition of this class. So structural perspective. It's not the only the class diagram. There are some other diagrams also, right? ER diagram. Okay, structural perspectives. Then there are behavioral perspectives. It shows how they behave, how they interact, how they process. So in UML, the most popular behavioral diagrams are sequential diagrams, communication diagrams, activity diagrams, and so even state diagrams. So those are behavioral diagrams. So you will learn each and every diagram, okay, in the semester 3. And this is different thing, okay, external way, right? How your system is looked at by other systems, external systems, or interaction perspective. How do you look at it as an interconnection of the system and the environment? So likewise, you can look at it in different ways, okay? Right, so I mentioned some of these diagrams, right? Use case diagrams we already discussed. I told you when it comes to modeling, we use modeling both requirement side and the designing, right? So class diagram, I told you this is the main diagram, main structural diagram, right? So these are more dynamic diagram, behavioral diagram, sequence, activity, even state, okay? Again, we use graphical method models, okay? We use graphical. All those diagrams are graphical representations. I keep saying that because human brain is optimized for understanding graphics, images, pictures. Right. So now we are going to look at some of those diagrams or models. Okay, models. Right. First one is context model. Okay. So context models are used to give you the big picture and how you look at it in different perspectives. Right? Context model. So those are the big picture diagrams, big picture, overall, overview diagrams. Context model. Context means the big picture. Sandarbha. So there you will see the system boundaries, the system, what is belonging to the system, what is outside the system. So you can see this shows The overall system functionalities, expectation. Say this, I think, health management system that they are mentioning in the previous slides also. So the patient record management, admission management, prescription management, appointment management, the statistics, right? And reporting module, management report. So this gives you the overview. And these are the functionalities. Anything outside these functionalities are not covered. So that is out of our scope. Right. So that is context models. Okay, context models. System boundary. Then there are some process related models. Process. It shows how the things are processed. Okay. So this is activity diagram. It shows how the things are processed. Right. Some activities happens parallelly. Some activities happens conditionally. If it is this, you do that. Otherwise, you do that. And some things can happen parallelly. And you don't have to worry about these exact symbols, because you just have to aware that there are models which we can use to model process, business process. So this is a very good example. This actually activity diagram. Okay, activity diagram. So activity diagrams models process aspect. Right. So then we have the interaction models. How they interact, how those components interact. So here the most important diagrams are sequence diagrams and communication diagrams when it comes to object orientation. Okay. So they show the interactions, how the different classes interact with others by passing message. Remember we discussed about message passing in semester 1 programming. Right. So use case modeling we already discussed. Right. Use case modeling we already discussed. That is the main modeling technique we use to document the high level requirements, overall requirements. Okay. So that we already discussed. So we already discussed, right? The example of a use case diagram. We have already discussed that. So sequence diagram is more into the interactions, how the messages are passed between different classes or components. Again, you don't have to memorize these things. You just have to get a feeling about it. Sequence diagram is something like that. It is more into the how they are interacting with each other, how they pass messages. So when we say pass message, yes, the user interactions, then different classes. So this class is calling a method in this class, and this class is calling a method in that class. It's a method called chaining that gives you the final result. This is another example of a sequence diagram. Okay. Again, this is just to get you the feeling of what is a sequence diagram. And you have to know that sequence diagram is, it's a sort of behavioral diagram, and also it's sort of an interaction diagram. It's not a structural diagram. It's not a use case diagram. Okay. Right. So the structural models. I told you the main structural model is class diagram. Class diagram. It shows you in general how these classes and interfaces are related through inheritance, association, generalizations, etc. Right. So here you can see that how they are related. Association. Patient is association with patient record. Patient record is associated to a patient. Right? Association between classes. So these all are associations. So this is the structure of a class. You must be familiar with this notation because we did the programming, object-oriented programming. Okay. Then the generalization and specialization. So there is another name for inheritance. Okay. So we discussed that in object-oriented. So say this is animal, say this is dog, this is cat. So dog is specialization of animal, cat is specialization of animal, and animal is generalization of dog and cat. Similarly, if you have account, say savings account, current account, savings accounts and current accounts are specializations of account, and account is a generalization. It's also structural aspects. In class diagrams, we show not only association, we show inheritance or the generalization. Okay. Something like that. And it's basically the inheritance that you learn in your semester 1, programming. Right. So then there's another concept called aggregation. Now remember association. Association එකෙන් හුටපටයක් තියෙනවා. මෙයාට පුළුවන් අරගෙන මෙතන කෝල් කරන්න. Association එකක් තියෙනවා කියන්නේ. Association එක නැති කෙනෙක්ගෙන් අපි උදව්වක් ඉල්ලන්න බෑනේ. මොකක් හරි කරන්න දෙන්න කියන්න බෑ. Association එකක් තියෙනවා කියන්නේ එයාත් එක්ක එයාගේ methods වලට අපිට access තියෙනවා. අපිට පුළුවන් එයාට කියන්න මෙහෙම කළා දෙන්න මෙහෙම කළා දෙන්න. නොදන්න කෙනෙක්ට කියලා කියන්න බෑනේ මෙහෙම කළා දෙන්න කියලා. So then the inheritance or the generalization, right? So specialization, say savings account and account, dog and animal. So then we have the aggregation. We are going to discuss these things in detail in your semester 3, okay? Object-oriented SAT. So aggregation means whole part relation. So we have whole and we have parts. Right? Whole and parts. So sometimes we call it composition also. Right? So earlier we used to call aggregation and compositions as two things, but these days we say that both aggregation and composition is whole part relation. Okay. Whole part means something like this. Order is consisting of order items. So when you go to the supermarket, what they print is ultimately the order. You will see it as a bill, but in reality it is order. And it has so many order items. So this collection of these order items is considered as the order. Okay. Right. So behavioral diagrams or behavioral models. Behavioral. So we already discussed some of the behavioral diagrams. I don't know why they have mentioned it again, like activity diagrams. Okay. Bit of state diagram is also behavioral. Right. So then we explained that there are data-driven applications, event-driven applications. So if it is a data-driven application, we have to go for data-driven modeling also, because our main focus is data. Right. Our main focus is data. Right. Like data mining, data and online analytical processing. So there data-driven modeling is there. So they are the software engineers mainly concerned in modeling the data. Then if it is something like robotics, right, agent technologies, it's event-driven modeling. Event-driven modeling. Right, here another example is something like weather forecasting, right, and things, marketing applications where you analyze huge number of data and so Google is one of the leader in data-driven modeling because their main business is analyzing data and come up with some useful solutions. Right. So another one is, now we will discuss data-driven, event-driven, then the state machine or state-driven. So we have another diagram, UML diagram also called state diagrams. Okay, state diagrams. So it moves from one state to another state. From that state, due to a particular event, it goes to another state. If you take order is initially new. Once the order is done, maybe order is once you do the payment, we can say paid state. Still the goods are not dispatched. So therefore still in the paid state. Maybe now the goods are released to the customer. Now we can say it's in the dispatch state. Okay. And also there's a possibility that the goods are returned due to damage or whatever. So likewise, it can undergo one stage to the other stage. Okay. It goes from one stage to another. Right. So now we are moving to the final part in our modeling part, the model-driven architectures. Okay. Actually, this is not a separate topic. When it comes to architectures, early days, we tend to take it as a concept only. But especially after UML in 1990s, we heavily bias towards model-driven architectures. Even when we are developing a software, we can think of it as different components that interacting with each other in a well-defined ways. Okay. So very good example is a class diagram. In class diagram, it's all about the classes, how they are structured and interact. And so UML is one of the main reason for model-driven architecture because we heavily model first part of the designing and refine it and make it sort of a perfect. Then only we start developing. Okay. Model-driven engineering. Okay. So another advantage, if we can further develop this model-driven engineering, is we can automate coding. So then software engineer has to model the software system and the tools are going to generate the code. So these still we are heavily doing coding. That is why there are a lot of job opportunities for software engineers, right? So we have to code. But you know that in a lot of other areas, we are now automating. So more and more tasks are done by the robotics and other systems. But unfortunately, in software development, we have to do a lot of things. In a way, it is good because it generates a lot of job opportunities. But in a way, it is if you look at it as a society, it is a lot of wasting of human effort. So if you can go for model-driven engineering, we will be needing less and less software engineers. So engineers only model, the tools will generate the code. So that is the idea behind model-driven engineering, but it's anyway, still it is in an early stage, right? So therefore we are not much using the model-driven engineering, rather we model it, but then we have to code it. The model is not capable of generating the code, okay? Right. And now this is a separate topic. We can think of different types of models. Okay, different type of models. And this is a very popular question in your paper also. The three type of models are computation independent models or CIM, platform independent models or PIM, and platform specific models or PSM. Okay, so the computation independent model means that model is sort of an abstract model. You don't have any computational things in that model. It's more domain related model or business level model. Okay. Then we have the platform independent model. So that means it is not as abstract as computation independent. Of course, the computational things are there, but we model it in a platform independent way. It's like we have modeled it in a technology neutral way, a technology neutral manner. So the third one is platform specific model, where our model is targeting a particular platform, maybe Java, because Java has some concepts like enterprise Java beans. There you have the session beans, entities, etc. Right? So then it's a platform specific model. Maybe it's specific to Java or specific to C#. So those are called platform specific models. Okay. So this diagram is extremely important, very, very important. So it's a sort of a transition where you start with computation dependent models, then platform independent models, then we can go to the platform specific models, and finally we can get the execution code. Now remember, this is model driven architecture. Here the idea is the architect and the designers do modeling, and different tools generate the next level things, and finally the executable code also. So the software developers have to do some fine tuning on. We are not going to do each and every code. A lot of code is generated, and we just have to write some fine tuning. Okay. And still, this is not a reality. We can't say that it's 100% reality, but there are some places we can use a bit of tools to automate certain tasks. Okay. So you will better understand this when you are doing the enterprise software development. Where there are a lot of tool supports, and the tools are going to generate a lot of artifacts, etc. And we just go there and do. I will show you one example. So some of you may have already used Eclipse. Okay. So we use IntelliJ, but in level 3, you will be using Eclipse. Level 3, enterprise application development. So there you have so many artifacts where you can, the code is generated by the tools. Code is generated by the tools. For example, I can say create a new session bean. Session bean or message driven bean. Okay. Or create a enterprise Java bean. So then it is going to generate. Now these codes are generated. Right? So these codes are generated. We just have to go and write small part only. I will show you another code. Right. Now this is Java servlet. Okay, Java servlet. Now this code is entirely generated by the tool. So we just have to write this part. All the others are generated. So that is what we are discussing here. Okay, this kind of development. Right. So we try to do as much as possible that kind of model driven development, because it really increase the productivity. Developers have less work to do. That is what we want to do. We don't want to do a lot of coding. Right. So computation independent model, some domain specific guidelines, it is translated to platform independent model. So for that one and some platform specific patterns, it is translated to platform specific model. To that, when you add some language specific concepts, it can generate the code, the final code as well. So it's step by step we are going towards the final code. Okay. So this is just an example. So this is Java side, how it can be done. Java side, that is what I explained using the Eclipse, okay, tool. And same thing you can done for .NET side. So in Java side, we call it Java Enterprise Edition, Java Enterprise Edition translators, Java Enterprise Edition specific modules, Java code generators, and the final program. Similarly, the .NET translators, .NET specific modules, C# code generations, and C# program. So Java and .NET are one of the two major software programming languages for enterprise development. In enterprise level software development, enterprise level means we use components. We expose them through web services and other remote method calls, etc. Okay, so of course you may not understand this concept right now because you have this as a subject in your semester 4. Okay, so there you will better understand this process, and actually you will find that we are going through these steps in your syllabus. What you have is this portion, because your syllabus we don't have the C#, but we have is Java Enterprise Development. So there you will see, actually you will experience this kind of development. Okay, right. Agile methods and model driven architecture. Right? You know that in agile development, we want to develop software in short cycles. So in a way, model driven architecture is beneficial because a lot of automations are there. Right? So then it can increase our productivity. At the same time, in agile development, we don't look at the entire system and do the entire architecture, entire design. We just take priority use cases and gradually we develop. So therefore, in a way, model-driven architecture is not practical in agile development as well, because in model-driven architecture, we have to do an overall modeling. But in agile development, we do a bit of overall architecture, but we are driven by use cases, high priority use cases, user stories. Okay. So therefore, it has both challenges and the pros and cons. Okay. Right. So that's it. Right. It's a bit of technical topic. And of course, the architecture is the most advanced part, right? So that is why only the experienced people become the software architects. Okay. But anyway, so today we discuss actually three topics: requirement engineering, architectural designs, and system modeling. Okay. So the next time we are going to discuss this topic, design and implementation. This is again continuation of the design and also the development. So then we have the testing and evolution. Okay. So most probably next day we can finish these three. Okay. We'll stop at this point. Right. Thank you.